In problem 3 we are given an impulse response which is very simple, just made of delta functions. Part A asks whether this is Bibo stable or not. We remember, if we know the impulse response, we can test for stability by checking if adding up all the samples of the impulse response gives us a finite value or not. In this case, since it's made up of just 3 samples, what do you think? Will the sum be finite or infinite? That should tell you whether it's stable or not. In B, you were asked whether it's causal or not. So a hint is, look at this term. In part C, we are asked for the frequency response Hw3 We already know the frequency response of the delta function is just 1, and that of the shifted delta function is e⁻j⁻A. So we have -1/4. Here the shift is +1, so it should be e⁻j⁻1 plus half times the Fourier transform of the delta function is just 1, then -1/4. The shift is -1, so e⁻j⁻. So this is the Fourier transform of this H. In D, we are asked for the magnitude and phase of Hw3. The hard way to do this is to write the e⁻ as cosine omega plus j sine omega, and this as cosine omega minus j sine omega, then trying to collect all the terms and finding these, but that will be very tedious. The smart way to do this problem is, we can see that these two will together form a sine or a cosine. So let's try that. We get half minus 1/4 times e⁻ j⁻ plus e⁻j⁻, and we know that e⁻jx plus e⁻jx/2 is a cosine x. So this term right here is simply 2 cosine omega. Here we had half minus 1/4. So our answer is going to be half minus half cosine omega. So what's the magnitude of this expression? It's purely real, right? It's a real number, so its magnitude is the same. It's going to be half minus half cosine omega. And what will be the phase? It will be 0, because it's a real quantity times e⁻j⁻. So the phase is 0. This is simply 1. Now to make plots for these, now we need to make a plot for the magnitude and the phase. So we know that the frequency response that we need to draw, it should vary between -pi to +pi. Same thing with the phase response. This would be the magnitude, this here would be the phase, and the phase we see it's 0 for all omega, so it's just going to be this. The magnitude is half minus half cosine omega. We know that the cosine omega has the shape, it's 1 at 0, 0 at pi over 2, and minus 1 at pi. We are multiplying it by negative half and adding half to it, so the result looks like, so multiplying it with negative half gives us something like this. And then adding the half to it gives us something like this. So it really looks like this, and very symmetric in the other direction. We can test it out in MATLAB. Define omega between minus pi to pi with an increment of 0.01. H is half minus half cosine omega. You make a plot, you label the axis, and we get this, where 3.14 is pi. For the last part of the problem, it is asking what type of filter is H of n. A low pass, band pass, high pass, what kind? So since it's letting through the high frequencies and blocking the low frequencies, it's a high pass filter.